let's talk about data science and statistics. So let's define statistics. The word statistics was basically coined by Gottfried uh, Eichenwald. He was there during 1719 to 1772. So he basically have derived the word from the Latin word called state, which means historically it was used by the governments while gathering any kind of demographic information, the likes of census or tax collecting. So statistics has the base comes from the word state, which is a Latin word. The statistics is basically defined as a science of collecting and analyzing statistics by Oxford Dictionary, since it is a discipline that concerns the collection, organization, analysis, interpretation, and presentation of data. So this term is also used as a synonym of data. So for example, statistics of a basketball game can be shown as a normal distribution, which is put across over here. So now let's look at the data types. What are the different data types? So we have already discussed it in our earlier slides as well, but then let's again have a quick recap. So in statistics, there are groups of individual data points which can be classified as belonging to any of the various statistical data types. So below are the most important data types. So you have nominal or categorical data. So let's talk about the nominal or categorical data. So if you see the blood groups, so you have A, B, AB or O. So these are the categorical data which we are using this across. Then you have the scale called ordinal data. So ordinal data basically helps you to rank uh, data in terms of the Likert scale. So you have 1, 2, 3, 4, 5 rating, and then 1 basically says you like it, 2 says somewhat like it, 3 says neutral, 4 says dislike it somewhat, and then 5 is complete dislike. So that's the ordinal data where you rank your entries. The last type is called continuous data. So in that you basically see the kind of distribution. So the age can be a continuous data. The height of people can be continuous data. So these are the examples of continuous data. So as we said, there are three types. The first is nominal or categorical data. Second is ordinal data, and third is continuous data. So these can be the different data types which are used in statistics. Now let's look at the frequency and cumulative frequency distribution. So the distribution of total number of observations among the various categories is termed as the frequency distribution. So if you see on the graph on the right hand side, you can see there's a histogram and a density curve. So the histogram basically shows the overall density or the nominal distribution. So if the data is continuous, data is discretized and plotted as a bar graph, and which is called a histogram. So that is demonstrated again on the right hand side. So now what is density curve? So density curve is a idealized description of distribution of data. So the area under this curve is called the density curve. So this complete curve, the area of this is the density curve. So if you sum of all the classes below the actual class, the cumulative frequency distribution can also be plotted instead. So if you do a cumulative frequency distribution, then you can have the plot created in this manner. So now let's look at the definition of populations and sample. So the prime objective of statistical analysis is basically to infer the characteristics of a group of data by analyzing the characteristics of a smaller sampling of group. So sample is a smaller representation of population. That is the typical definition of sample. So in statistics, a population is also called as universe, is basically a set of similar items or events which is of interest for some amount of question or experiment which is under the consideration. So that is the definition of population. So it is the set of similar items or events which is of interest for your experiment. For small population, we can obtain all values. However, the populations are normally so large that obtaining all the measurements are not feasible at all. So now let's talk about what is sample. A sample is a set of individuals or objects collected or selected from a statistical population by a defined procedure. To sample a population randomly, it requires that each member of the population has an equal and independent chance of being selected. So that's how you basically sample anything out of a population in a random order. Now let's look at the measure of central tendency. So there can be a question asked from this slide. So we should be very clear in terms of understanding what is mean, what is median, and what is mode. So these are basically the measure of central tendency. So in last slide we talked about population and we have talked about samples. So now the measure of central tendency is basically called pertaining to the sample. So in samples as well as in populations, one generally finds a preponderance of values somewhere around the middle of the range of observed value. The description of this concentration near the middle value is called average or measure of central tendency. So you say that average, it can be defined, the measure of central tendency can be defined in form of mean, median, or the mode. So now let's look at the measure of variability and dispersion. The variability or dispersion of data is basically an indication of spread of measurements around the center of distribution. So what are the most common range of measuring the variability or dispersion? The first important is the range. Range is basically the distance between your lowest and the highest value of distribution. That's how you define the range. Then interquartile range. So interquartile range is basically a spectrum in which the middle 50% of the values lies. So it's a difference between the first and the third quartile. The next is your standard deviation and the variances. So standard deviation or variances is basically the average distance of all the measured value from the mean value. That's how you define the standard variation. You define the standard deviation, and then square root of standard deviation is called variances. So relationship between the statistics and probability. Let's look at these important aspects. So probability theory is fundamental to statistics. So you have statistics, which basically helps you to understand the data and the respective causes for it. So probability theory is one of the subset of statistics. So statistics helps you to understand the causes for the data, and then probability basically helps you to derive the data based on the kind of causes. So that's how the relationship between statistics and probability is quite intertwined. So now let's talk about the difference between the probability and statistics. Probability is the occurrence frequency of anything given out of a sample. So you have rules and you have data, and probability is basically based on the rule what is your occurrence frequency, that is probability. And statistics is basically you have the data and you work out for the sample or population. Now let's look at the probability theory. So probability theory is a branch of mathematics concerned with the probability, which measures how likely an event is supposed to occur. So that's the probability theory. So it was triggered by the desire to predict the outcome in the games of chance popular among the French nobilities of mid 17th century, such as cards or dice. So earlier work basically was done by writers such as Girolamo, Cardano, or Galileo. So these are the days when the scientists started working on understanding the probability theory. So it was developed between the two great French mathematician Blaise Pascal during 1623 to 1662, and then Pierre Fermat during 1601 to 1665. So probability theory was basically developed by the French mathematicians.